Question 13. We have a lab that's running 4 different experiments, so we're going to look through these. They're all described below. They're insect populations, and what we're going to do is the function that's being spoken about is the number of days t since the start of the experiment. Okay, so we're being asked to write an equation. So remember, population typically grows exponentially, and we can see each of these have, well, 2 of them have percentages, so that would definitely be exponential. There are this one down here, which is an amount that's going to be actually a linear growth, so we'll see that. So remember, if it is linear, an amount of growth, that's going to be y equals mx plus b, where m is the rate, b is the starting value. If it's exponential, then we're going to have y equals a times b raised to the x, where the a is our y-intercept, our starting value, initial, yeah, I guess I got that right. And then b is sort of the rate. It's the percentage either above or below 100, depending upon whether they're increasing or decreasing. And we'll see how that works. So for A, we have 1,000 insects starting initially, and that it's increasing by 20% each day. So an increase means we always start with what we had, 100%, and in this case we're going to add 20% to that each day. So that's 120%. And then we're going to divide this by 100 to turn it into a decimal, right? 1.2. So our function, I guess we could just use y, but we could also use f of x or maybe I of x for insects. And they want us to use t, so we'll do f of t equals 1,000 times 1.2, so that's our daily rate, our factor, to the t power. Okay. If so that's A. If we're decreasing by 20%, well, that's sort of the same type of thing. Let's change colors a bit. Yeah, we'll go this way. So we start with the 100%, but we're decreasing, so we're subtracting 20%. Which means we're only getting 80% back, so they're dying off for some reason. We divide this by 100, and so we're going to get 0.8 as our factor. And so our function here is going to be f of t equals 1,000, because that's what we started with, and our factor is going to be 0.8 to the t. Now we'll see we have to switch gears a little bit, because we are saying that h increases by 20 insects. That's an amount of increase. Let's see, let's go with this one. So it's an amount. It's no longer exponential. It's not percentage change. So what we know is that we have a starting value, a y-intercept of 1,000, and we're increasing by 20 each day. That's an average rate of change. It's a slope. So what that's telling us is our slope is 20 and our y-intercept is 1,000. So that's going to be y equals, I like to go with the start first, so let's go with 1,000 plus, because we're adding, we're increasing 20t. Maybe I should do f of t, right, instead of y, but okay, we'll do that. So that should match there. This last one, now it's a little bit, we don't see a percentage, but when we ever talk about doubling or tripling, then that is actually an exponential process, because double means we're continually multiplying by 2, right? On day 1 we multiply by 2, day 3 we would not multiply by 3, we still multiply by 2. So we're repeatedly multiplying by 2. So we can think of this one is going to be, we have our function is going to start with 1,000 insects. On day 1, we're going to double. Double means to multiply by 2. So that would be 1. After the second day, we would multiply by another 2. So for each day, we're multiplying by 2. So that would be our function there.